Hello, everyone, and welcome back to the AWS Expert Series podcast. I'm Pradeep Rao, and thank you for joining me. Over the last few months, we've talked about securing AI and ML workloads, implementing zero trust on AWS, preparing for the post quantum era, and modernizing Layer 7 DDoS protection. Today, we are tackling another transformation that's quietly changing software engineering itself. The biggest shift in DevSecOps isn't that developers are writing code faster. It's that software is increasingly being written by non human agents. AI coding assistants and autonomous development agents can generate features, refactor applications, create infrastructure as code, write tests, fix vulnerabilities, and even submit pull requests with very little human involvement. This changes one of the most fundamental assumptions in software security. For decades, security controls assumed a human developer was responsible for every line of code. Today, that assumption no longer holds. AI can generate thousands of lines of code in minutes, recommend third party packages you've never evaluated, produce IAM policies that are far more permissive than necessary, or even introduce vulnerable dependencies before anyone notices. The software supply chain is no longer only about developers, repositories, and CI/CD pipelines. It now includes AI prompts, model context, agent permissions, external tools, package ecosystems, and automated decision making. Securing this new software supply chain requires a different mindset. The first thing we need to understand is that AI generated code isn't simply another developer productivity feature. It fundamentally changes the threat model. Traditional developers understand organizational standards. They recognize business context. They understand why certain services are restricted, why production changes require approvals, or why least privilege matters. An AI coding agent has a completely different objective. Its goal is task completion. If the prompt asks for a feature, the agent will optimize for delivering that feature. Unless we provide security boundaries, the agent has no concept of acceptable organizational risk. AWS recently highlighted several emerging risks associated with AI coding agents. These include prompt injection attacks, context manipulation, excessive IAM permissions, unintended production changes, insecure infrastructure configurations, hallucinated software packages, and expanding access through Model Context Protocol or MCP integrations. These are not theoretical concerns. If an AI agent can access source code repositories, infrastructure templates, deployment pipelines, documentation, ticketing systems, databases, cloud APIs, and production environments simultaneously, the blast radius becomes significantly larger than a traditional IDE. Security, therefore, has to evolve from protecting developers to governing autonomous software generation. Let's talk about the first stage of the software development lifecycle, author time. Author time security happens while code is being written. In an AI assisted world, this is where many organizations still have the biggest visibility gap. Instead of allowing AI assistants unrestricted access, AWS recommends defining steering documents that clearly establish organizational security expectations. These documents specify coding standards, approved architectural patterns, dependency policies, encryption requirements, logging expectations, and IAM guardrails before the AI writes a single line of code. Think of these documents as security policy for AI rather than documentation for humans. Equally important is limiting what the AI agent can actually access. Modern AI development environments increasingly use the Model Context Protocol, allowing agents to interact with external systems such as Git repositories, databases, ticketing platforms, cloud services, and documentation portals. Every MCP connector effectively expands the AI's attack surface. Following least privilege becomes just as important for AI agents as it is for human identities. An AI agent that only needs to read source code should never receive production deployment permissions. An AI agent creating documentation should not have unrestricted AWS credentials. Security teams should continuously review which tools, APIs, and cloud resources each AI agent can reach. The second control point is build time. This is where AI generated code should encounter deterministic security gates before reaching production. Regardless of whether code was written by a senior engineer or generated by an AI assistant, the validation pipeline should remain exactly the same. Every commit should undergo static application security testing, software composition analysis, secrets detection, infrastructure as code scanning, dependency validation, policy as code enforcement, container image scanning, and automated compliance checks. A WS code pipeline and a WS code build provide excellent orchestration points for these security controls. The important principle is that security becomes automated, repeatable, and independent of the code author. Whether code originates from a developer, an AI assistant, or a future autonomous coding platform shouldn't change the pipeline. The pipeline itself becomes the trusted decision point. Another interesting recommendation from AWS is avoiding approval fatigue. Many organizations assume every AI generated change should require manual review. That sounds reasonable until AI begins producing hundreds of pull requests every week. Eventually, reviewers stop paying attention. Instead, reserve human approval for high risk changes such as IAM modifications, networking changes, encryption configuration, privileged infrastructure, authentication logic, or production deployment workflows. Routine low risk updates can continue through automated policy validation. Now, let's discuss one of the most important concepts in modern software supply chain security, the Software Bill of Materials or SBOM. If AI can generate dependencies faster than humans can review them, organizations need a continuously updated inventory of everything entering production. This is where Amazon Inspector becomes particularly valuable. The Amazon Inspector SBOM generator can produce software bills of materials from container images, local directories, archives, file systems, compile binaries, and operating environments. Instead of simply identifying known vulnerabilities, an SBOM answers a much more fundamental question: what exactly is running inside my application? AWS recently introduced a powerful enhancement to the Inspector SBOM generator through a plugin architecture. Organizations can now extend SBOM generation using lightweight Lua plugins without recompiling the entire tool. This allows security teams to collect metadata from proprietary frameworks, internal package managers, unsupported languages, niche ecosystems, and rapidly evolving AI development environments. That flexibility matters because AI coding agents increasingly introduce libraries that traditional scanners may not immediately recognize. As software ecosystems evolve, visibility must evolve at the same pace. Unfortunately, attackers are evolving just as quickly. Software supply chain attacks have become significantly more sophisticated over the last few years. Threat actors now target package ecosystems rather than individual organizations. AWS has recently documented campaigns where malicious actors published compromised or deceptive packages that appeared legitimate while secretly delivering malicious payloads. We are also seeing entirely new attack techniques. Typo squatting tricks developers into downloading packages with names nearly identical to popular libraries. Slop squatting exploits AI hallucinations by publishing packages that exist only because AI assistants incorrectly recommend them. Fragment level attacks hide malicious functionality across multiple components. Long term trust building campaigns slowly establish credibility before introducing malicious updates months later. Some malicious packages activate only under specific runtime conditions, making detection far more difficult. The attacker is no longer trying to fool only developers. They are trying to fool AI coding assistants, automated dependency scanners, CI/CD pipelines, and even security validation tools. Supply chain security has become an adversarial machine versus machine problem. So, what does a secure AWS reference architecture look like? At the developer layer, AI coding assistants operate within well defined steering documents, specification files, and tightly scoped MCP permissions. Source code is stored in protected repositories with branch protection, signed commits, mandatory pull request reviews, and security policy enforcement. AWS Code Pipeline orchestrates automated validation. AWS Code Build executes SAST, SAY, secrets detection, IAC scanning, policy validation, and container security checks. Dependencies are resolved through AWS Code Artifact using trusted repositories rather than arbitrary public package sources. Amazon Inspector continuously generates and analyzes SBOMs while monitoring newly discovered vulnerabilities. Amazon Guard Duty complements this by detecting suspicious runtime behavior that may indicate supply chain compromise after deployment. Together, these services establish multiple layers of defense from prompt creation all the way to production runtime. As we wrap up, I'd like to leave you with three important messages. First, AI generated code is fundamentally a software supply chain challenge, not simply an application security challenge. Second, trust should never be based on who or what generated the code. Trust should be based on automated verification through repeatable security controls. And finally, visibility is everything. If you cannot inventory your software components, validate your dependencies, understand your AI agent's permissions, and continuously monitor runtime behavior, you're operating without the foundation required for secure software delivery. The future of DevSecOps isn't about slowing AI down. It's about building security controls that operate at AI speed. Organizations that embrace automated guardrails, policy driven pipelines, SBOM driven visibility, and least privilege AI identities will be far better positioned than those relying on manual reviews and traditional development assumptions. The software development lifecycle has changed forever. Our security architecture must evolve with it. Thank you for listening to this episode of the AWS Expert Series podcast. If you found this discussion valuable, please subscribe, share it with your colleagues, and let me know which AWS security topic you'd like me to cover next. I'm Pradeep Rao. Until next time, stay secure, keep learning, and I'll see you in the next episode.